Next is trigonometry in all quadrants. So as we learned before, we have trigonometric ratio in the acute angle and in the obtuse angle. Now, how do we find the other values more than 180 degrees until 360 degrees? So the rule is still the same. We use sine theta is equals to y over r, cos theta equals to x over r, and tangent theta is equals to y over x. So before, if we have theta as the acute angle, I can say that sine theta, cos theta, and tangent theta here are all positive in the first quadrant. So we divide into 4 quadrants. Yeah, this is the first quadrant, this is second quadrant, this is the third quadrant, and this is the fourth quadrant. First quadrant is between 0 until 90 degree. Second quadrant from 90 until 180. Third quadrant from 180 until 270, and the fourth quadrant from 270 until 360. So taken from before, in the second quadrant, well, when theta is obtuse, we can have sine 180 minus theta as the obtuse angle equals to sine theta. And we have cos 180 minus theta, it will be equals to minus cos theta. And if we have tangent 180 minus theta, it equals to negative tangent theta. And using the same method to find all of these values, for the third method, we will have sine, the third quadrant is 180 plus theta. So this will be equals to negative sine theta, because if we draw the third quadrant here, so this is negative y and this is negative x. So both sine and cos will be negative. So sine 180 plus theta equals to negative sine theta. Cos 180 plus theta equals to negative cos theta. And tangent 180 plus theta will be positive tangent theta, because negative y divided by negative x, positive. And for the fourth quadrant, we use the 360. So sine 360 minus theta will be equals to negative sine theta, because in the fourth quadrant, this is negative y, but positive x. So y will be negative, so sine will be negative. Cos 360 minus theta will be equals to positive, because x is positive. And tangent 360 minus theta will equals to negative tangent theta. So the thing that we can see from here, if we use the values 180 and 360 in the relationship between the angles in all quadrants, so the function is still the same. So sine equals to sine, cos equals to cos, and tangent equals to tangent. But if we use the 90 and 270 degree, the function will change. So if you use this 90 degree, so second quadrant, will be sine of 90 plus theta. And cos 90 plus theta and become tangent 90 plus theta. And the function will be changed. Sine become cos. This is positive because sine in second quadrant will be positive. Cos become sine, but cos in second quadrant is negative. And tangent is also negative. Tangent become cotangent. That's for the second quadrant. For the first quadrant, it will change also using the sine 90 minus theta will become cos theta. Cos 90 minus theta will become sine theta. And tangent 90 minus theta equals to cotangent theta. That's for the first quadrant. The third quadrant. So we have 270 sine 270 minus theta, cos 270 minus theta, and tangent 270 minus theta. And sine in third quadrant will be negative, so this will be equals to negative cos theta. This become cos is also negative, so this is become negative sine theta. Tangent will be positive, so this become cotangent theta. And for the fourth quadrant, we use 270 plus sine 270 plus theta, cos 270 plus theta, and tangent 270 plus theta. So sine fourth quadrant is negative, so we have negative cos theta. Cos fourth quadrant positive, so it's equals to sine theta. And tangent fourth quadrant is negative, so negative cotangent theta. So my suggestion is you just need to use the 180 and 360 to have the same function across the quadrants. If you use 90 and 270, the function changes. Sine into cos, cos into sine, and tangent into cotangent. But if you use 180 and 360 in the conversion, you can have the same trigonometric ratio. And from all of these quadrants, we can see that in first quadrant, all trigonometric functions are positive. In the second quadrant, only sine positive. That's why it's S, only sine. The third quadrant, only tangent positive. And on the fourth quadrant, only cos is positive. Yeah, you can see from here. Second quadrant, only sine positive. Third quadrant, only tangent. And in the fourth quadrant, only cos positive. We continue to the trigonometric graph. We have three basic trigonometric graphs. For y equals to sine x, it will start from 0. Yeah, if we plot the numbers, so sine 0 is 0. So we start from 0, and then sine 90 is equals to 1. Remember, this is from the unit circle. Sine is y. sine theta, ya. So that means we only focus on this vertical y. So when theta 0, the y is 0. When theta is 0, y equals to 0. When theta is 90 degree, when theta equals to 90 degree, it will y equals to 1. Yeah, when theta is 90 degree, so it's equals to 1. So that's why at 90, this is 1. And then in the second quadrant, this is the first quadrant, second quadrant, from 90 until 180, it will decreasing because of the identity sine theta is equals to sine 180 minus theta. And then for the third quadrant, sine will be negative. Yeah, you can see here, sine is negative in the third quadrant. So we're using the sine 180 plus theta equals to negative sine theta. And for the fourth quadrant, sine also negative. So sine 360 minus theta equals to negative sine theta. So the graph will be maximum at 90, yeah, 1, and minimum at 270 at negative 1. And it passed 0 on the 180 and 360. So from this, we can see for the sine, it has maximum 1, minimum also negative 1. The amplitude is 1, and the period is equals to 360, because after 360, it will repeat again the pattern. So we can say that sine has period of 360 degree, because every 360 degree, it will repeat the values. That's for sine. Cos. For cos, now we have to check from x. So x equals to cos theta. So cos 0 is maximum, yeah, 1. So we start from 1, and then 0 at 90, minimum in 180, 0 again into 70, and maximum again in 360. And the same, this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. So from here, we can see that cos has the period of 360 as well, because after the 360 degree, it will repeat. And the maximum and minimum value, maximum of cos is also 1, and minimum is also negative 1. So similar to the sine, but different in the position of maximum and minimum value. How about tangent? Tangent, we can see that here, tangent has no maximum or minimum value. Yeah, the maximum and minimum value of the tangent should be infinite and negative infinite. So tangent has no amplitude. If sine and cosine has amplitude of maximum 1, yeah, tangent has no value of maximum and minimum. But if you check from the table, we have tangent 90 degree equals to infinite. So that means in 90 degree, since tangent 90 is equals to sine 90 over cos 90, so 1 over 0. So this is technically undefined. So there is an asymptote in the tangent graph. So asymptote is the line that never being cut by the graph. So the graph will never touch this line. So we have two asymptotes in tangent graph. First is 90 degree, and the second one at 270. And if you see from the graph, the tangent has period of 180 degrees because it will repeat after 180. So every 180 degree it will repeat. So that's the characteristics of the three trigonometric functions graph. Now, so we can have the general formula for the trigonometric functions. We have y equals to a sine a bx plus c, y equals to a cos bx plus c, and y equals to a tangent bx plus c. And I put the note here, a will be the amplitude except for tangent, yeah? Not for tangent, because tangent has no amplitude. B is the number of the period. So that's why it's 360 degree divided by the period for sine and cos, but 180 for the tangent because tangent has a period 180. And C is the vertical translation of the principal axis. What is the principal axis? The principal axis is this. So where the value of 0, yeah? So we can see the example. Y equals to 2 sine x plus 1. So we know that sine maximum 1, minimum negative 1. And this is multiplied by 2. So 2 will be the amplitude. And in here, A is 2, B, the number in front of x is 1, and C equals to 1. That means the principal axis will be lifted 1 unit upwards. So if we remember the basic graph for sine is start from 0 and then like this. So it maximum at 90 and then minimum to 70, maximum 1 and minimum negative 1. But now, because we have plus 1, so everything should be lifted by 1. So the principal axis now, it's not in the x-axis, but in y equals to 1. So I can draw it here. So this is y equals to 1. And it starts from the principal axis when theta equals to 0. So when this is 0, it starts from the principal axis. So start from the principal axis. Maximum in 90 degrees. Since b equals to 1, so we still have the maximum at 90 degrees. So at 90 degrees, it will be maximum. So what's the maximum value? Sine maximum 1. Now it becomes amplitude is 2. So it's 2 times 1 and then plus 1. So the maximum value will be equals to 3. And the minimum value will become 2 minus 1 plus 1 is negative 1. So the maximum will be at 3. So 90-degree maximum at 3. And then minimum at 270. 270 minimum in -1. So minimum here 270. And it cuts again the principal axis at 180. So at 180, cut the principal axis. And 0 again, the principal axis at 360. So here. So the graph will be like this. Maximum here and then down. Pass through the principal axis. And then minimum 270. And then until 360. So we can see from here, the amplitude now is 2, not 1, because of the A equals to 2. So this is the graph of the 2 sine x plus 1. Y equals to cos 2x minus 2. So the same, cos has maximum of 1 and minimum of -1. So what is the maximum value? The maximum will be 1 minus 2, because cos has maximum 1. And minimum will be -1 minus 2. So this is equals to -1 and -3. So we know that the amplitude is 1 and the B is 2. And the C will be equals to -2. So the principal axis will start at -2. If you remember the graph of cos, we start at the maximum value at 0. And then 0 in 90-degree, minimum 180, pass 0 again 270, and maximum 360. So we can put it on the graph. But now B is 2. So we know that B is 360, because this is cos, divided by the period. So if B is 2, that means the period will be divided by 2. 180. So that means all values in the x here, in the x-axis, will be divided by 2. Because the period now divided by 2. So all the values in the x should be divided by 2. So if it's 0 at the principal axis at 90-degree, so in this graph, it will at the principal axis when x equals to 90 over 245. So it will be here at 45. So because 90 divided by 2. And then its minimum at 180. So in the new graph, it will minimum at 90. So it will minimum at 90. So minimum is in the -3. So minimum here. And then principal axis again at 270. So divided by 2 is 135. 135, so it's here. And then maximum at 360 divided by 2, 180. So 180 will be maximum at -1. So here, 180, and maximum at 0, yeah? So we can start to draw it. This one, minimum, and then back up again until maximum. Now, you can see here that the period now reduced to 180 degrees. It's not 360 degree anymore because of this 2x. So that means until the 0 until 360 degree, I can draw two graphs. So it will maximize again in here. And it will have a next value in the principal axis for 180 degree. So 45 plus 180 is 225. So it's around here. And for the next value of the negative, from here, it added by 180 degree again. So it is 135 plus 180 is 315. So it will around here. It will be 0 in here. And the minimum will be added by 180. The minimum will be 90 plus 180 is 270. So it will be minimized here. So you can see we can continue the graph. So now we have two periods in between 0 until 360. So we have 2 times of the cos graph with period 180. So you can see now we have 2 periods of 180 degrees because of this number. So 2x means in the normal one, if y equals to cos x, so we have only one graph with the period of 360. But if we have cos 2x, so that means we will have 2, because in the 360 degree, in this 360 degree period, we will have 2 graphs with periods 180. So from here, we have to extend the number of solutions. So if before we have only 2 solutions, maybe now become 4 solutions because of this additional region, because of the smaller period. So that's for cos. Now move on to the trigonometric equation. So according to the graph before, we can find the solution of the trigonometric functions. So that's called the trigonometric equation. So if we talk about trigonometric equations, that means we have to solve the equations. So for example, like this. Solve sine x equals to half. So that means we have to find the intersection between y equals to sine x and y equals to half. So we can draw it 90, 180, 270, and 360. So sine start from 0, maximum at 1, 90 degrees, 0, minimum, and 0. So like this. Okay, I put it here. And intersection with y equals to half. So half is here. So if we see, now I have 2 solutions, here and here. I have to find that intersection point. We know that the one is between 0 until 90, and the other one will be from 90 until 180. So how do we solve this? So we solve using the inverse of trigonometry. So sine x equals to half, so x equals to sine inverse of half. So we have to find the inverse function of sine. half, and this is equals to 30 degree. Now, the 30 degree is the answer for the first quadrant. We know that this is 30 degree. This is 30. And don't forget, we have to prepare the possibilities for the other answers within region. So we have to add by k times the period. Yeah. To prevent, there are more possibilities within the period of the domain. Yeah, because we can add one more period. But since in our graph, yeah, we can see that there are only two answers, one answer in first quadrant and one answer in the second quadrant. So we don't need to find the other possibilities. So for k equals to 0, so x equals to only 30 degree. And the other answer should be in the second quadrant. We know that sign positive in quadrant 1 and quadrant 2. So this is the answer in quadrant 1. And for quadrant 2, we can have, using the identity, 180 minus 30. So it's plus 360. So equals to 150 plus k times 360. So when k equals to 0, x equals to 150. So this will be 150. So we only have two solutions within this domain. Two, solve cos 2x plus 1 for negative 90 until 270. So we prepare the graph. So for this, I can have cos 2x equals to minus 1. So that means the 2x will be equals to cos inverse of minus 1. If we draw, so 90, 180, 270, 360, oh, it's until 270 only, but from negative 90. We know that cos start from 1 and minimum at negative 1, yeah? So start from 1. But since this is 2x, so that means everything should be divided by 2. The period itself should be divided by 2. So the normal one will be minimized at 180, yeah, 0 and 90, minimized in 180. So that means it will be minimal in 90 because we divide by 2. So minimize in 90 and then maximize in 180. Maximize in 180. So like this. And then we add again, it will minimize because the period now is 180. So minimize again in 270. Like this. And for this, we minimize also in negative. So like this. So that means now we find the intersection between cos 2x, cos 2x, y equals to cos 2x, and y equals to negative 1. So y equals to negative 1 is this. So we know that there are three answers here. So 2x here will be the cos inverse of negative 1 is equals to negative 1 is equals to 180 plus k times 360. So x equals to 90 plus k times 180. So for k equals to 0, x equals to 90. For k equals to 1, x equals to 90 plus 180 times 1 equals to 270. And k for -1, x equals to 90 plus -1 times 180. So it's negative 90 degrees. So we have these three answers. Number 3, solve 3 tangent x equals to √3 for -pi until pi. So we can simplify this. Tangent x equals to 1/3 √3. And if we draw the tangent, it has the asymptotes at 90. So this is pi/2. This is 3 pi/2. The region is between -pi until pi, so this is pi. And we have another asymptotes in -pi/2. And then this is pi. So the normal line of the normal graph of the tangent is this. So it will be like this, yeah. Now we have to find the intersection between y equals to tangent x and y equals to 1/3 √3. So 1/3 √3 is between here, around here. Y equals to 1/3 √3. So during this region between -pi until pi, we expect to get 2 intersection points. So we can solve this. So x equals to tangent inverse 1/3 √3. So this is equals to pi/3, 6, yeah? Plus the period of the tangent is 180, or in this case is pi radian. So for k equals to 0, we have x equals to pi/6 in the first quadrant, yeah? This is first quadrant, yeah, we know that this is the first quadrant. And the other solution should be in the negative region. So I can put k equals to -1. So I can have the value of the previous region. So when I put negative k, the k is negative. That means I'm looking for the value for the previous. If I put k equals to 1, 2, 3, positive values, I'm expect to find the value next on the next period. Yeah. So if I put k equals to -1, so x equals to pi/6 minus pi equals to -5/6 pi. That's it. So we have two answers between this region. Next is trigonometry identities. So using this unit circle, we have x as the cos theta and y, this is x, yeah? And this is y equals to sine theta. And according to the Pythagorean theorem, x equals to cos theta, y equals to sine theta. Well, using the Pythagorean theorem, since this is the right angle triangle, so x squared plus y squared equals to 1 squared. The hypotenuse is 1 here. So x squared plus y squared equals to 1 squared. So if we replace, so this will be cos theta squared plus sine theta squared equals to 1. Or I can write as cos squared theta plus sine squared theta equals to 1. So this will be the identity. From this identity, I can produce the values of sine or cos theta for the substitution if we want to prove the identities later on. So from here, I can have sine squared theta equals to 1 minus cos squared theta, or I can have cos squared theta equals to 1 minus sine squared theta. So we can use this rule in the identity proving. That's the first identity that we have. And the second identity, we can use tangent theta as the division of sine theta and cos theta. So these two identities that we can use for this AS material topic. Yeah, I think that's all for this discussion so far. For the miscellaneous questions, it will be discussed in the other video. So please check it out. Thank you and bye.